So today I'm going to be introducing Dr. Peter Moyle. Just for a little bit of context, you'll remember that the first 2 weeks ago we gave a little definition for environmental flows. We talked about the history of water management in California and a little bit about the history of water policy in California. Last week, Dr. Pasternak came and gave us a overview of some of the physical processes, about how geology and geomorphology provide that template for the water and the flows to flow over, and a little bit of how we measure hydraulics and water dynamics for environmental flows in streams. And he sort of alluded to some of the ecological aspects in terms of how we model and do hydraulic modeling. And then this week, Peter's going to come and he's talking about fish and flows, and he's particularly going to be talking about an example in Poudre Creek where they implemented environmental flows under a more natural flow regime. And so this will really help put some context into the ecology and the fish and how fish and flows work together. And then at this point, will set the stage for the next upcoming weeks where we'll be moving more into policy discussions and different case studies for how environmental flows are sort of looked at and viewed and maintained around the state. And so with that, I'll introduce Peter. Thanks, Peter.
Thanks, everybody. I thought I'd better warn you that about halfway through this talk, I have an exercise for the class to do. So, or everybody at the class, everybody can do it. And if you have some paper and pencil, that'd be great. Otherwise, I have some paper we'll pass out, but unfortunately, I don't have any pencils. And the talk today is, say, Fish and Flows. No, it's Poudre Creek. I'm working on a book right now on environmental flows, and about 6 months ago, I wrote a chapter on fish and flows. And I looked at the chapter, I thought present that chapter for this lecture is really very boring, I discovered. So I decided I'd go back to something, a version of a lectures I've given in talks and classes, and from everything from classes to policymakers, which is on Poudre Creek and the relationship of environmental flows to the management of Poudre Creek. And it's really being held up as an example of a successful restoration project where flows were a key to it. And flow is usually regarded as sort of the master variable. You've really heard that in that class. It's regulates water temperature, waters our riparian plants, provides habitat for fish, floats boats, dilutes pollutants, does all these wonderful things. And Poudre Creek is a perfect example. Without water in Poudre Creek, which was what it was like when I first came here, it was a mess. It was just a ditch with riprap and everything else along it, old car bodies and trash in the creek, and generally not much in the way of flows. And the general concept you want to get across here is that if you're interested in protecting native fish and native birds, native invertebrates, whatever it is, there's a general relationship here this is grossly oversimplified, of course, which is that the more you alter the flow, the more you're going to get away from the original fauna that was there. And in California, we have a special problem. We have invasive non-native species that have been introduced of all categories. And they're really fully integrated into the landscape now. But generally, when we're doing restoration projects and managing for flows on a creek, we're interested in native fish and native critters. So basically, what this shows is the idea that the more the flow is altered, the fewer native fish you'll have in the system. The amount of flow alteration is usually associated with dam building one way or another, but it doesn't have to be. And this is the typical, you've seen these kind of graphs already. This is for the San Joaquin River, which I'll talk about at the end of the lecture. But you notice the blue line is the natural hydrograph, and the red line is the altered hydrograph, flat lining of the river. Obviously, that's a very different system. If you're a fish living in there, if you're a non-native fish, you're probably very happy. If you're a native fish, you're probably very unhappy. And this is where Poudre Creek comes in. And it's what you can call a novel ecosystem. It's an unprecedented ecosystem, or no analog system, or however you want to look at it. This shows you what it looks like from the air. If you've ever been along Poudre Creek, you know it goes up from the Coast Range, it flows down into the Yellow Bypass. But what you see is this is a very intense agricultural environment with the creek flowing in this narrow channel that's levied on both sides through this agricultural environment. and you start looking closely at the vegetation, at the plants, the trees, the fish, you find a lot of non-native species are present. So, and this is fixed in place. Historically, the reason Yolo County has such rich soils is that this creek used to meander like a fire hose back and across the landscape in different years, and the sediment coming down from the Coast Range would spread out across the landscape, creating these really rich soils. Well, now it's confined to this one channel, and the soils are being used up rather than being created. And so here's a picture of the creek in a spring flow period. And so, you look at this. Can we get the lights down a little bit? Is there a way to do that? Or will that interfere with your camera?
Let's try.
Okay, just even a little bit would be helpful. This is a picture of the creek in spring flow. You say, wow, that really looks nice. The flowers are blooming, the trees are green, everything looks great. But then you start looking at where these things come from. You got eucalyptus from Australia, tamarisk from Asia. The sedge is along the edge is native. And the creek itself, we have this section mostly native fish, but the crayfish are not native. There's mud snails, a recent introduction from New Zealand. We have arundo from Asia. Lots of native birds, native oak trees, but this very natural looking system that's a mixture of native and non-native species. And they're all watered by the creek. That's the one thing they have in common. This is all riparian species that need this water from the creek. And this is where Peter Creek comes in. Again, I hope some of you are, if you're familiar with the basic landscape around here. If you're not, you should be. Because the ultimately source well, the ultimate source is Cobb Mountain over here somewhere, but it's Lake Berryessa, flows for 8 miles down here. It gets the Peter Creek Diversion Dam, where most of the water is diverted into Solano County for the cities of Fairfield, Vacaville, and so forth, and mostly for farming in Solano County. And then the section of the creek I'm going to be talking mostly about goes from Peter Creek Diversion Dam all the way down here into the Yolo Bypass. And it's subject to the major restoration projects. But most people think of this Pewter Creek on campus as the Arboretum Waterway. That used to be Pewter Creek. The original Pewter Creek, when Davisville was first settled, the people saw that Pewter Creek, and it was flooding the city all the time. So they moved the creek, found an old channel, moved it over a mile or so it would no longer flood the city. Then it also cut way down. So we have a very artificial system here in so many different ways.
You have gone to Pewter Creek Brewery?
I'm sorry?
The brewery? How many of you have gone to Pewter Creek Brewery?
Pewter Creek?
That Peter Moyle is mentioning is like what, 5 miles?
There's the Pewter Creek Brewery, you say?
Uh-huh.
Well, there is one in Berryessa, but the important one I'll show you a slide of is the Budweiser beer. If you open a can of, get a pan of Budweiser beer that says made in Fairfield in it, you're drinking Pewter Creek water. So very important. Anyway, here's the dam, Berryessa. This is the diversion dam. Now, when the water gets down to the diversion dam, 95% of the water is diverted and used for other purposes. So here's the Budweiser beer plant, the Pewter South Canal delivering the water to Solano County. The diversion down there. So this is 95% of the water is diverted, 100% of it's between levees. So what kind of a system do we have? We were talking about needing, wanting a natural flow regime, wanting to create a habitat for native organisms. How can we do this in a system that's like that? I don't know what's going on here. I'm messing around, I guess. Anyway, so here, Lower Pewter Creek is a history of abuse. When I arrived on the campus in the early 1970s, the university was actively mining the gravel from the creek for university roads. Car bodies lined the creek. There were old refrigerators everywhere. It was generally pretty much a mess. And then we got severe drought in the 1988, 89, and 90 was one of the worst droughts up to recent times along the creek. And that prompted some very action to restore the creek. But you here see a dry beaver dam, the bicycles going up the main channel of the creek. The creek just generally dried, and that's what it would do periodically, is dry up. So obviously a very hard system to survive in. And the fishes obviously do not do very well under those situations. But here's the drought of 2012, 2016, actually worse than the 89-90 drought. And you see, this is in February 2014, at the height of the drought, when everything was just, we hadn't had any rain for almost 12 months. It was really looked awful. You can see how dry everything looks. Everything is still brown. This is February, which is normally a pretty green month, yet you see water in the creek. So what's the difference? Well, the difference was a lawsuit. This is a lawsuit brought by the Pewter Creek Council, the City of Davis, and the University of California. Very unusual to have the university join in a lawsuit like this. University of California versus the Solano County Water Agency. The trial was in 1996. There was a settlement agreement in 2000, which resulted in flows down the creek. And the basis of this settlement was this section of the Fish and Game Code, which says the owner of any dam shall allow sufficient water at all times to pass through a fishway, or in the absence of a fishway, allow sufficient water to pass over, around, through the dam to keep in good condition any fish that may be planted or exist below the dam. That keep in good condition is crucial, and that's where I come in, because I got to help design the flow regime for the creek. And also I developed a definition for what it means to have fish in good condition, this is obviously a very vague statement. I got to define that in ecological terms. But the key is that you can use that then, use this law to require the owners of dams to release water down streams that have been dry. So the question then becomes, how do you determine a flow regime for a creek like this, especially one that's as artificial as Pewter Creek is? What do you do? And especially when you realize that you have only a small amount of water to deal with. You're not going to get all the water back. 95% of the water is still going to be diverted. What do you do with that remaining 5% of the water? Well, this diagram shows you a typical regulated river like Pewter Creek. And this is where eventually I'll have you do a little exercise here. But what you obviously, the water usually out of a dam like this usually comes out of the bottom, so it's quite cold. And it warms up as it goes downstream. Depending on if you get tributaries, in Pewter Creek's case, there are no real tributaries coming in during the summer months, especially. So basically, the water equilibrates with air temperature. As you go further downstream, it gets warmer on a pretty regular basis. Clarity is high where it's cold, and very green where it's warm. There's a lot of algae because it's such slower velocity, because the gradient is much lower downstream than upstream, and pool depths tend to increase as you go downstream as well. So the lesson here is that the habitat's changing dramatically from a fish perspective as you go from upstream to downstream. So where are the fishes? That's sort of the question here. And this is your warning. I want you to have some paper. I'm going to be looking for volunteers in a short time to help design a flow regime for the creek under different scenarios. Because what you have in a creek like Pewter Creek is not just one species, but multiple species. And fish are what people think about. You could easily do this for invertebrates. You could do it for birds even. As a matter of fact, another talk I could give, I usually give with Melanie Truan, is about how the birds and the fish and the plants all kind of have the same general patterns of distribution in the creek. But here we have rainbow trout. This is the rainbow trout likes clear flowing water, gravel riffles for spawning, lots of cover. This is what we're talking about, efficient flows. They need this. This is what they need. This is what the flows produce. They produce these gravelly riffles that they need. They need loose gravel so they can dig in and spawn, lay their eggs in it. They need lots of cover because that's the hide from fishermen and others. And they need insects as food. And the flows of the river all provide all this. And this is where I'm giving you a very simplified version of it. I thought this would be better than giving you a bunch of graphs from public publications. And the riffle sculpin, this is the kind of fish people don't care about so much. It occurs only with trout, but it's like a trout, only even more sensitive. It really likes cold water. It gets down into the rocks where it's a small bottom, ambush feeding, it feeds on small insects and so forth. This fish is only about 4 inches long. And fishermen like it because there's a fly that fly fishermen use called the muddler minnow, which is a sculpin imitation. So trout will eat the sculpins as well. But this is another example of a cold water fish, likes the clear cold water. Then we get down a little bit lower where the water is cooler, but it's not quite so cold. It warms up more in the summer. And this is an example of one of the native fishes that lives there. This is the Sacramento pike minnow, a species found only in California. It's endemic to this part of the world. And that's one of the things that makes Peter Creek important, because most of the native fishes we're talking about here occur only in California and only in this region. So here's a pike minnow in its typical habitat. Again, it likes clear, cool water, not quite so cold as trout, but a little cooler. It likes flowing water. It likes some depth. It likes to have a few pools around that are greater than 1 meter deep. It doesn't have to be, but that really helps a lot, especially for the larger adults. This is a fish that gets up to 1 meter long, so it won't in Peter Creek, but it can get pretty big. They like this dense cover. You see it's hanging out under these branches and things that have fallen into the water. Wood is very important. Riparian, this is one of the interrelationships between the trees and the banks. The water makes the trees grow. The trees then fall into the water, and they make cover for fish. So here's the fish hanging out in the cover, where it's waiting to ambush small fish for prey. This is a predatory minnow. The member of the minnow family has no teeth in the jaws. So interestingly enough, then we have the living vacuum cleaner, the Sacramento sucker. This is a species that gets up to 1/2 meter long or so. It has what we love to call fleshy papillose lips. It's a very kissable fish. It loves these clear flowing, like the pike minnow, likes the clear flowing water. It likes some depth. It doesn't have to have it again. It likes cover to hide out in, but it basically is swimming up and down the stream, browsing on the rocks, with these very fleshy lips, sucking up small invertebrates and algae, scraping material off the rocks. But again, it likes the same kinds of habitats that the pike minnow likes, and the two are usually found together. Now here's another example of one of our very unusual native fish. This is the tule perch. All its other members of this family are found only in saltwater. It's a member of the surf perch family. What's so remarkable about this fish is it's a live bearer. This is a female that we caught just as it was giving birth. These little fish here are active. They'll just swim away once they're born. And the males become sexually mature within a month after being born and are actively courting females, which can then store the sperm. They're an absolutely remarkable life cycle. This looks like a very unlikely stream fish. Here's a deep-bodied fish. You think, how can this fish make it in the rivers? But they do. Matter of fact, when you snorkel in a place like Peter Creek, you come across concentrations of them like this in pools where they're just hanging out in the water under deep cover. And the females get to be like little footballs when they're pregnant. They have a single female can give birth to 40 young. And they need this deep cover because they can hardly swim. Then, of course, they want the cover for the young as well. So, but they need the cool water again. They don't like very warm water. They need the cool water. They need the flowing water. They need deep cover, I mentioned further. And then they need lots of invertebrates that are on the food, on the logs and on the bottom for food. Now here we get to into the lowermost reaches of the creek, where we have largely non-native species that are present. This is the largemouth bass, my token non-native species in this talk. What they really like is warm, quiet water with deep pools, lots of vegetation, and they feed on fish. So they want fish and crayfish. They want a place where there's lots of small bluegill and other kinds of fish around, as well as the crayfish. So this is a predatory fish. It likes warm water. If the water's too cold, it can't reproduce. But then we add to all these fish, and these are just a small fraction of the fish that are present in the creek. There are roughly 15 species present in the creek most of the time. Here's the Chinook salmon. I'm very proud of the fact that we now have a run of Chinook salmon going up Peter Creek. This last winter, in November and December, we had roughly 500 salmon spawning in the creek, and some spawning right here on campus. The Chinook salmon have their very special requirements. They like cold water. They're like the trout. They're cold water fish. But they need some very high flows in the fall to bring them in. They respond to when they come up into a stream to spawn, because they're going to come up to spawn and die. when they come up, what they need is the right smell, either the smell of other salmon that are up in the stream, or the odor that a rain delivers to a stream. Think of rain coming down, washing dirt off the landscape, giving flavor to the creek, so these fish can tell that there's a habitat upstream. And so they need these, and then they need a high flow pulse, because these creeks get very low in the summer. So if they've got a high flow coming down, it means that they can make it upstream by swimming through the higher water. It also washes out beaver dams and things of this nature. So you need a high pulse of flow water in the fall, and then you need some fairly constant flows in the spring, because you want to move the juvenile salmon out. They've hatched out of the gravel, and they need to get moved downstream in the spring. And for most of these juveniles, once they're out of the system, that's it. There's no more salmon in the system. So for about 3 or 4 months, you have no salmon in the system. There's some exceptions to that. But what they need is really high quality riffles with spawning gravel. They don't need any food because they're spawning and dying. But they need good riffles to dig into. They bury the eggs, and the young hatch, and these little juveniles like this pop out of the gravel, forage for a while in the creek for a month or two, grow to 10 centimeters or so, and then bail out and head downstream. And there's a pair of spawning salmon in the creek. It's really quite spectacular. These fish can be a meter or so long, and are spawning with pairs. And right now, one of the best things that's happened in the recent years is, there's a pedestrian bridge in winters that crosses the creek, a railroad bridge. You could actually stand on that bridge and watch salmon spawning. Again, that's what gets people excited about the creek, and that'll be the next part of this talk. Okay, so this is where you try to figure out, how do you design a flow regime that benefits all these fish? I assume you want to have all these fish around one way or another. The pike minnow sort of represents the native fish resident native fish community that we'll talk about. But you can see if you're the optimal habitat for the pike minnow is where it's not too cold and it's not too warm. It's sort of the Goldilocks habitat in the stream, and the water's fairly clear. It's got lots of cover. So basically, you have trout in the cold water and bass in the warm water. So this is the basic pattern that you're seeing here, is a segregation of the fish partly by temperature and gradient. For trout in cold water, I'm trying to remember what I was doing here. The bass and sunfish in the warmer water. So this is where I want you to design. Actually, I should go through this again, because the trout habitat's in the cold water. And basically, if you want to increase trout habitat, you got to release more water from the dam. That's a fundamental thing that a lot of lawsuits have been made on that basis. We want a fishery for trout in the dam, therefore you got to release more water. The more water released, the further downstream your cold water goes, the longer it takes for it to equilibrate with air temperature. So the more place you have for a fishery. And then for bass and pike minnow, you want as much. On the other hand, you might say, well, we want as little flows as possible, especially during the summer months, because we want to maximize the amount of warm water. You want some flow, but you want to maximize the amount of warm water habitat that would be upstream. So these are the kind of choices that you can make. So how do you design then a flow regime for a regulated river? Where your basic goals are to maintain viable populations of fishes, of desirable fishes, and then balancing the human and ecosystem needs for water. This is what I increasingly call reconciliation ecology, the idea you have to reconcile diverse interests in order to come up with a flow regime. And here are the constraints. Only 5% of the unimpaired flows are available. In other words, you have to work with the water you have. The Solano Water Agency is a very good water agency, but their mission is to provide water for farming in cities. And they have very limited water available for the creek. So they're always going to provide you with they can ask, what's the minimum we can get by with in order to have a viable population of fish in the creek. Then, of course, different interest groups want different fishes. If you're a bass fisherman, which there are a lot of them in California, you want to have the maximized amount of bass habitat. Matter of fact, largemouth bass are probably the most fished for fish in Peter Creek right now. If you're a salmon fisherman, you want to maximize salmon habitat so you can increase productivity of salmon. These fish will go out to sea and then get caught in the commercial fishery. If you're a conservationist, you say, well, we want those native fish. They're rare. Let's maximize the habitat for them. So how do you do that? That's one of these things we want to try to do today. So what I want to do is to have you attempt to draw a flow regime that would benefit one of these four species here: the Chinook salmon, largemouth bass, native fish, or rainbow trout. Can we get this board out? I have a board here.
Can I turn the screen?
Oh yeah, you turn the screen off. Okay. Now some of you are going to be on television. I'm going to need 3 volunteers because what I want to do is draw the salmon diagram, draw the salmon flow. And then so think about volunteering or anybody need paper? I want you to be drawing these while we are up here. Anyone needs some paper, wants to draw a flow regime? Nobody, you're just going to sit there quietly? Okay. Okay, so first off, let me just try the flow regime for a salmon. The first thing I mentioned was that, well, you really need spring flows, you need a spring pulse that, really good flows in the spring and a pulse that pushes the juvenile salmon out to sea, pushes them down the creek, gets them out of the creek because most of the creek is too warm for them in the summer. So then you can drop it way down in the summer, and in fact, in the summer months, you can get by with very little water. Matter of fact, when I was involved a number of years ago in a settlement agreement for the Tuolumne River, the fish agencies were only interested in Chinook salmon, and they said, we don't care about summer flows. We'll use whatever indigenous water is there, that'll be fine. I was one of the few people in the room who said, we got some other fish in the creek besides salmon, and they like water. So this is actually a very real, but people have argued you just don't need water in the summer for salmon. But then you need a sharp pulse in the fall because the fish are downstream. They're looking for a place to come up and spawn. You need a pulse to bring them up. And then once they've spawned, once they're up there, you got to have good flows for them to spawn in, and that takes you down into the spring. So you need higher flows in the winter months to provide habitat for the juvenile salmon that are buried in the gravel and then are hatching out and are feeding on the edges. So now I'd like to have someone of you come up and I need 2 people initially, one to do a graph for bass and one for trout. Anybody want to try? Anybody brave enough to try this drawing a flow regime? I do this with freshman students. I get lots of volunteers. So Lisa's good. Okay. Which one do you want?
Like trout.
Okay. You're gonna design. This is the ideal flow regime for,
The ideal one.
or whatever flow regime you want. Create a flow regime that you're a trout fisherman. You want to maximize habitats for trout.
I would assume since they're resident, you would want relatively high flows.
Okay.
Year round. I know that's extremely boring.
Yeah, that's very boring. But you know, most trout releases from dams are like that. Only thing I would add in there is a spawning flow. It's bring them up into some spawning habitat, maybe a slight increase in flow at one point to bring them up. But in fact, most of the time when you have these trout, that's what they do. It's very good. Who wants to do bass? Anybody? How about somebody telling me what you think of bass flow regime? If you're interested in bass in the creek, what would you do? Remembering that you want to maximize warmwater habitat.
Very uniform low flows,
You would
but enough to get water downstream.
you want just enough water to get downstream,
You don't want
and
it to be too shallow because they do like this habitat, but you don't want it to be too cold.
yeah, okay. What you want is some kind of a minimum flows for habitat. Maybe you could increase flows in the winter a bit, but you don't even have to do that. Again, this is sort of like the trout, only you're even lower down. The idea is that from an irrigation district perspective, you could actually even drop them way down at this point of when they're the hottest months of the year, because the fish then would be confined to pools in the lower part of the creek, and that'd be fine. That's sort of the way the creek was before we installed our flow regime. So there are various ways that you can manage the creek for that. How about native fish? What would you do for native? What would you pay? Tell me what you do for fish, native fish in the spring. One thing I did not tell you about native fish, they're all spring spawners. They all like to move up into a creek, and like all fish, they respond to a flow and increased flow with the spring.
So you want that curing flow.
So you want, okay, that's the one thing you want for sure is a fairly long period of high flows in the spring, or spawning and for rearing.
Sort of like a snowmelt recession.
Yeah, it'd be sort of like a snow, only obviously we don't have one here. Snowmelt recession is the idea that historically many of these streams you have a peak flow in the spring caused by melting snow or by rain. In this case, obviously we don't have it, we have a dam upstream. So one of the things that you want to do for native fish is to have some fairly high flows in the spring, and again, stuff sort of like salmon, you want to encourage the fish to spawn, and it certainly doesn't hurt also if you had a peak flow in here as well. But you want these fish to spawn, and then you want have a miniature floodplain develop along the edge of the stream so the juveniles can rear little baby larval fish. Okay, how about in the summer? What do you want to do with the native fish in the summer? Increase flows, keep it the same, lower it. Again, you think of it, you're trying to balance human needs and fish needs. Would you lower the flows? Because we're just talking about holding habitat. These are fish but they like the cool water. So the more, if you have cool water in the stream, more water in the stream, you're going to have more habitat for them. But then you have less habitat for some of the other fish.
Summer's when the human need is greatest.
When
That's when you're irrigating. When
yeah.
the human need is greatest.
Summer is when the big demand for
Also,
water is. Yeah.
also this creek probably dried out quite substantially during most summers, so I would assume they're adapted to.
So you would drop it down? Like so?
Yeah.
And that's actually what they do in Peter Creek. Very good. Okay, how about fall? That doesn't matter. Anybody
I'll
else?
let somebody else.
Anybody else want to do a fall? How about fall? What do you think happens in the fall months? Yeah, the fish have all spawned. All the juveniles are fairly large at this time. They're hanging out in the pools and then they're underneath the cover. The air temperatures are starting to get cooler. Do you think you can get by with less or more water? Anybody? How about a little even less water if you would need it be? Because the fish just need to hang in there. And then you go back in, same thing's true in the winter months. You can go, and in fact, you often get very minimal flows in the winter. Then you can bring it up again for the spawning in the spring. Anyway, the whole idea of this exercise was thinking that when we designed the flow regime for Peter Creek, there were 4 of us who spent several days in a room together with lawyers sitting behind us, talking about all these various aspects of creek, about what they need, what do these fish need, what are the characteristics of their habitat, what kind of flows do they need for spawning, and so forth. And then how do you balance all these conflicting hydrographs here? How do you make them so you maximize the habitat for fish in general? So we get back to the slides. Whoops. I'm running out of time too.
Full screen. You just have your display.
Oh,
Great.
okay. Okay, so basically in Pewter Creek, you needed to have these these 4 communities of fishes that you wanted to have flows for. The trout, when you need cold water flows all year round. The native resident fish, which need cool water flows. And the native resident fishes, when you think about, these are the ones that really need the natural flow regime, something that resembles what the historic flow regime was like, which is Mediterranean climate, high flows in winter and spring, low flows in the summer. Warm water fishes basically want minimal flows. And then the Chinook need these more complicated flow patterns that I talked about. Well, when we negotiated the flows on the creek, this is basically what we came up with for what we call the natural flow regime. We decided we wanted to mimic as much as possible what the natural flow regime of the creek had been, which, as I mentioned, was some very high flows when the rains came, and typically in the winter, but there were also very low flows in the summer. But what we figured one thing we needed for sure was not to have the creek dry up again. So you negotiate and say, okay, what we want is a minimum for flows for the entire creek year-round, a living stream all year round. Now, this was important not only for the fish, but obviously for all the riparian vegetation and so forth as well. We wanted these flows to go into the creek all the way down into the Yolo bypass. Matter of fact, the criterion was there had to be 1 cubic foot per second, flowing down the creek when it reaches the Yolo bypass, which required the Sato Water Agency to release about 20 cubic feet per second at the dam. And that was 27 miles downstream to have that much loss of the water. So that was the first basic requirement, just keeping it a living stream, probably the single most important requirement. Then we argued it had to have high flows for at least 6 weeks in the spring. Those high flows would be the spawning and rearing time for the native fishes, and also provide lots of rearing habitat for the salmon, for their eggs and so forth. Then in addition, we argued for a pulse flow in the fall that would bring the salmon up. And this is basically the flow regime the creek has today, very variations on this particular theme. And that's basically what we got in the creek today is a trout fishery right below the dam, about 15 miles of native fish habitat, warm water fish habitat in the lower 5 miles or so of the creek, and salmon, a run of salmon coming up the creek. We don't know if these salmon have hatchery origins. We don't know if they're self-sustaining yet, but we know they're successfully spawning. So this flow regime then has had a lot of success. But the thing is, a flow regime is never just enough. That's all. The flow interacts with habitat. But I always say the flow is just the most essential ingredient. If you don't have the flows, nothing else really works very well. And this shows you the extremes that we've gone to. This is the Pewter Creek in winters in 2011 when they wanted to they had to remove a cement dam, fill in some deep pools, create some place because the stream was so confined between riprap banks it couldn't meander at all, create some room for it to meander. And in order to do that, there were some natural flows coming down the creek. They put those creeks into these massive pipes to bypass the restoration area, which was about a mile long, until they could work in the creek bed without a heavy machinery. Again, it's sort of an anathema you think about when you think of doing stream restoration, trying to restore natural habitat, but you're in there with bulldozers. And then this is a scene where these people are all here rescuing fish. Well, this is what it looks like today. This is in December, not the best time to be out there. This is that same general area. Flowing stream, this is a sign that says, don't get too close, the salmon are spawning here. You can see there's a wide natural reach where it supports the diversity of fish. In other words, this kind of restoration enables you to do more with less water because you created a habitat, you optimize the habitats as much as you can for the fish. And one indication of this is just the native fishes. This is one of our sites, which is downstream at Stevenson Road at the Graffiti Bridge, if you know where that is. And basically, before we started this restoration, before the trial in 1991 to 1997, what little water there was in that creek at that point was dominated by non-native fish, carp, goldfish, largemouth bass, green sunfish. After the restoration flows and the other things that are being done, this is only up to 2008, the native fish is completely dominated. And even today, that's close to 100% native. So we essentially designed a flow regime that works, but it works because of all this other material going on as well. And so what does it take to generate to manage Pewter Creek to make this natural flow regime work? Well, first off, you have to have a cooperative water agency. The Solano County Water Agency was a bitter opponent during the trial. Once after the trial, they came around and said, "We're tired of fighting, let's work together." And ever since then, they've been a major sponsor of things going on in the creek. One of the things that was part of our settlement agreement for the creek was to hire a stream keeper. This is a unique position, but somebody whose job is to maintain the creek and apply for grants to do restoration, to work with landowners, do everything he can to maintain the creek as natural habitat. And I'll introduce you to show you a slide of that in a minute. It also requires community involvement. You gotta have the local communities involved or it's never gonna work. And the best side of that, there's a very active organization, the Peter Creek Council. You have to have landowner cooperation. Most of the land along the creek here is privately owned. So most of the creek does not flow through public land. So if you want your project to be a success, you've got to work with the private landowners. And then you need monitoring. We're lucky we have a major university along the creek. They fund, the Solano Water Agency funds the research that I do. They fund a lot of research the Museum of Wildlife and Fishery does on the birds and the plants. And so the basic idea here is to try to recreate a natural flow regime with the various aspects of this flow regime, including the riparian plant production. Anyway, this is Rich Mirovich, who is the stream keeper. He's a former, he wasn't not a biologist, he was a farmer before he became a stream keeper. A great choice, because he knows how to talk to people, and he knows how to write grants. And he's been successful enough to get about $10 million worth of grants for restoration on the creek. Then you have community involvement. The people of Winters and Davis love the creek now, and they didn't before. It was trashed. Nobody came down it. So they got lots of volunteer help for planting and doing other, hauling trash out of the creek and so forth. Again, the Solano Water Agency has been very cooperative. They still get 90% of the water, but they do a lot for they make sure that the water that's left in the creek, its use is maximized for the desirable purposes. Their motto is "Be green, save blue." Landowner cooperation. A lot of the places you see along the creek are in good shape. Like the best spawning areas for salmon are all on private land, and those are landowners who are so enthusiastic about protecting the salmon. They pretty much keep all people out, even us researchers. But it's a good thing. Monitoring and research, because there's a lot going on. We know what's going on in the creek because of the monitoring. That's very important. So the take-home messages I want to give for this, first off, the flow regimes I've shown you is the societal choices to determine which species are present. In some streams in California, they're managed just for rainbow trout, and that you just need more cold water for that. I also like to emphasize we're in novel ecosystems now, systems that have combinations of species from all over the world that are seemingly getting along with each other. But that means you have make some differences in how you manage those streams. Another take-home message is that really understanding the ecology of the fishes is really essential to managing the creek and finding out what they need. And monitoring is critical for that. Too often we get restoration projects which there's no monitoring involved after it's done. You just let it go and assume it's going to work. It's much better if you can monitor continuously and then can adjust your habitat restoration according to what you find out. And another take-home message, of course, the natural flow regime is a good starting place. You got to start somewhere. And once you have a flow regime in place that you've designed and you have some idea what you want that flow regime to do, you can make it work for a lot of different things. Well, this is my other take-home message. We are the gods of these novel ecosystems. You know, we're in charge. We get to choose what we want here. This is a nice thing about a novel ecosystem with fish and plants and animals from all over the world. We can choose which ones we have around, which ones we don't, and we're doing that actively. Right now, we're basically acting in favor of the native species, but it doesn't have to be like that. Can I do another 5? Okay, I'll go through this real quickly. This is the lessons from Butte Creek have been applied elsewhere. The biggest restoration project in California right now is on the San Joaquin River. And that was This is actually when I took these photos in 19, it must have been early 2000. Anyway, this is the San Joaquin River as it was, a dry riverbed for much of its length. As a matter of fact, what you saw on the San Joaquin, this is 150 miles of river that was dried up. The water, basic riparian water rights kept water in the creek down here, so you had permanent flow. Whoops, darn. You had permanent flows. Going the wrong way. Oh no.
Sorry, hold on.
You can get me back there? Okay, you have permanent flows in the creek. I was trying to show you the map that shows you where the reaches of the stream that were dry. Why the lessons of Peter Creek were great. Well, you can get to the end.
Sorry, guys.
That's my problem. I clicked the wrong thing on the.
There we go. Can you click your clicker? Oh, wait, hold on.
You can give a quick refresh of what I talked about. Okay. Okay. Too far. Anyway, these reaches that are dry. These reaches here were ones that had egg return water in them, and the only reach that had natural flows was or at least river flows was this reach one up there, where they were releasing water to satisfy riparian right holders. So what do you do with a creek like this? 150 miles of creek, much worse shape than Pewter Creek. Once again, there is a lawsuit. And the settlement agreement in 2006, and the definition of good condition and the idea of the natural flow regime that I developed for Pewter Creek, or a bunch of us developed for Pewter Creek, was taken out wholesale into the San Joaquin River Agreement, which was really nice. They got the first experimental flows in 2009. I might actually mention that it took 18 years. The settlement agreement between the time the trial was won and the settlement agreement took 18 years. And there's major restoration going on throughout the area. But this is the headline of the paper. It's Fresno Bee yesterday. For the first time in 60 years, spring run Chinook salmon reproduced in the San Joaquin River. Spring run, when Friant Dam was built, they shut down the river. And that time there was a run of 50,000 salmon going up the stream, and they let it die. That could not be done today. But in those days, regarding using the water for crops was regarded as much more important than maintaining fisheries. We have this major restoration program going. You can see there's the unimpaired hydrograph. This was a 1993 hydrograph for a wet year. You can see it wasn't a regular hydrograph. And then a proposed hydrograph for a wet year. What you're going to see in the San Joaquin River now is a quote-unquote natural flow regime, one designed to provide habitat, especially for spring run Chinook salmon. And this is what my idea of what the creek will look like once we get these flows really established. The drought set all this back, of course. But the spring run Chinook salmon up here, fall run Chinook salmon dominating the reach down below, with native resident fishes in the cool water, and then with non-native fish in the warmer water at the lower end of it. Obviously, during the warm summer months, a lot of this river is not going to be suitable for salmon or trout. But this is an idea. This is what this flow regime that's proposed will probably do to the river. And you'll have a living river. You'll be a place people can recreate, canoe, kayak, as well as fish for its entire length. So this is what we hope is the future of the San Joaquin River. Lots of nice riparian habitat and large runs of Chinook salmon coming back up again. Now, that is a dream. It's still very controversial. There's still a lot going on there. But it's the kind of thing we can do in California and do very well. So that's what I have. I'm happy to take questions or discussion. Sorry, it took longer than I thought it would.
No.
You're all convinced? Yes.
I don't know what the projection is for if climate change continues at rates that it does now, but if you had an event where you had an extreme drought event, what would happen if it became?
Okay, that was actually one of the interesting, many arguments we had during the Pewter Creek trial, what do you do? Basically, at the time of the trial, the Solano Water Agency was so convinced they were in the right that they thought they would win no matter what. And when we won the lawsuit, won the trial, they suddenly noticed that we had in there a requirement that every 5 years they would release a very large amount of water to do geomorphic flows in the creek. And that we had no provisions for drought in our version of the which was what the judge had awarded. So after that, the settlement agreement was partly about the Solano Water Agency agreeing to do a lot of things downstream, but in exchange for that, they'd have drought provisions. And the drought provisions was that under almost all circumstances, you maintain those minimum flows at 1 cubic foot per second down at the Yolo bypass. That was the most important thing to keep going, to keep it a living stream. All the other requirements would go away. For the San Joaquin River, they're still arguing about this. They don't really know what they're going to do. But if this last drought was any indication, the flows would be a lot less, and sections of the river would probably be allowed to dry up again. So that's dealing with the realities of the water demand and so forth. Yeah.
I have a follow-up question to that. So in the drought then on Hood Creek, did you see a fall or a decrease in the native fish populations by just having to go?
Well, interesting, there was a slight decrease in the native fish populations only because there was less, there's enough natural rainfall that comes into the creek to create a spike and that really helps the spawning of the native fishes. We did not see that during the drought, so there was some slight decrease, but not a lot, and it wasn't as much reproduction. So, but Pewter Creek's a very fortunate stream from this perspective because it's got a huge reservoir. Various is a large reservoir, and the rain hits Mount Cobb, which is one of the highest points in the Coast Range. And one of the worst ways, one of these storms come across California, they hit Mount Cobb first. So that sometimes gets 50, 60 inches of rain a year. That all drains off into Pewter Creek, into the various reservoirs. So typically, the Solano Water Agency regards Pewter Creek as having at least 5 years worth of water in it for their purposes, without any cutbacks at all. So it's a big reservoir for a small stream, and so we have a lot more flexibility than most people do. That's why the San Joaquin is so much more difficult. It's a relatively small reservoir for a very large river. Yeah.
Other than in the courts, what other forums have you seen or been a part of that for sort of successfully negotiating these various interest groups for the river, whether it's irrigation districts or sportsman communities?
Well, I've been involved in a number of FERC arrangements, Federal Energy Regulatory Commission. That's one of the big ones. Those are again, it's a quasi-legal proceedings, though, where you actually are cross-examined and so forth. There are various arrangements. Pewter Creek and the San Joaquin River are being used by various water agencies as reasons to negotiate rather than fight. And you've seen that. Yuba River is certainly an example of that. There's a lot of good examples of that are sort of never publicized because they happen in a nice fashion. So you're going to be seeing more of that, just because it's practical, and because the water agencies see that if they have flows that are harming the fish, they know they're liable, and Section 5937 of the Fish and Game Code has been on the books for over 100 years and was never applied really very seriously until the Pewter Creek case, and that sort of sent a message through the water community that there's strong legal reasons why you have to provide water for fish. Yeah.
I'm curious about this on a very general scale, ideally nationwide. How often do you see these kind of really meaningful efforts to restore natural flow regimes coinciding with efforts to restore natural habitats, or is it usually kind of completely separate processes?
Well, the lawsuit was all about 5937, which is strictly, Fish and Game Code, strictly about flows. That's what the lawsuit was about. But everybody realized that it really was about everything else too. The Pewter Creek Council, an example of an environmental organization that was dedicated to restoring the creek, and they were getting involved in doing stream restoration even before we had the flow regime settled. So, but certainly once you had the water, it just made it so much more easier to do things. People were much easier to convince it was worth spending their time hauling out these old cars out of the the stream bed, creating a spawning gravel for salmon, all these things. It's much easier to convince people to do this if you have water in the creek. And also, the water in the creek meant the riparian vegetation was growing, you had more birds, you generally had places people wanted to hang out. So it makes, the flow has made a huge difference. Yeah.
After determining these minimum flows that are needed for the various native fish, did you ever find that a minimum necessary at any point in time was greater than that 5% that the water district was going to give you? Did they ever give in, okay, I'll give you 8% or?
Yeah, the flow regimes, generally if there's natural flows added to the creek, we can keep it. But actually what happens when, like for a pulse flow, the pulse flow to bring up the salmon, if there's a rain that's happening, which is a good thing, it increases the flows of the stream naturally. The Solano Water Agency can cut back on their releases. They can, sometimes they do, sometimes they don't, but they actually like it when their required releases coincides with a natural event that increases the stream flow. That means they can save water. So, but the only requirement is that the flows be there. It doesn't say anything about the source of the water. But the Solano Water Agency today is a very different organization than it was before, and they're very conscious of trying to do things that keep the fish going in the creek. Yeah.
I saw the hydrograph on San Joaquin. There was a wet year hydrograph.
Yeah.
And I was wondering, if you don't have snowpack as an early indicator of the type of water year, have you seen an example where the type of water year, wet or dry, drought, has been used to dictate the release schedule? You have that information kind of late in the year.
Actually, in all these, even in Pewter Creek, there are release schedules for wet, dry, and very dry years. Yeah. So I brought it a very simplified picture, like trying to do one flow regime. It's really the pattern I was after, but in fact, all these creeks have, all these streams, the flow regime is modified according to how much water is available. Pewter Creek's a little luckier because we have so much water in the reservoir, but by and large, they can cut back on the higher flow requirements. Like the pulse flow for salmon, for example, is probably the first thing that gets cut. And that's the sort of thing they can do if the levels are too low in the reservoir. And that's all written into a very long document about regulating the flows of the creek. So it's a very interesting thing to think about. That's why it takes so long to figure out what is a natural flow regime for the creek, because you have to look at it from not only from the general pattern perspective, but for what do you do during drought and very wet periods, what would you do differently? Yeah.
I was wondering if there's any sort of physical barrier on the San Joaquin River between where the spring run and fall run should be, or if it was just temporal?
I think yeah, that's a very item of discussion. There's no natural barrier now. Matter of fact, you want these fish to be able to get out. And the fish right now, people are so intent on trying to get any salmon going up there that I don't think they care too much. But the reality is that the spring run they're using, it's probably getting too much down in the weeds, but anyway, the spring run they're using are from the Feather River hatchery, which are partly hybridized with fall run already. They're not pure spring run, but they're great because they have the spring run life history. And the fall run then come in and have a slightly different spawning times and come in down lower. So the idea is they'll naturally segregate. I'm sure they won't, but at some point. But for right now, the assumption is natural segregation will separate the two runs, which is sort of, and then this fall run come up on their own. The spring run have to be hauled up. So another difference between the two. Yeah.
Has anybody looked at what trying to keep PFAS around does to the non-native, or the native fish, like how migrating Chinook salmon?
Oh yeah, no, we haven't studied that in the creek yet. It's a big major, throughout Central California, that's a major item of discussion. Will predator control help you increase salmon numbers? And by and large, we've concluded it won't. In Pewter Creek, the salmon are moving down under high flows when the water's pretty cold. And that's when the bass are least active. So our best guess is that it's not much of a problem, but it is just a guess because we haven't studied it.
Is anybody studying something like that?
I'm not aware of any studies on small streams like Peter Creek, but it's certainly, there are lots of studies on predation that show predation of other fishes on salmon that show in some situations it's a problem, in others it's not. In Peter Creek, my guess is it's not, because if the fish have to move out, if they aren't out by the end of March, they aren't going to move, they aren't going to make it because the lower end of the creek's too warm. Other comments, questions? Well, thanks, everybody.